Venture with me to the outer reaches of our solar system, where the sun's warmth becomes nothing more than a distant whisper. Here lies a world so cold that methane doesn't flow as a gas or liquid, but exists as solid ice crystals scattered across its frozen surface. Time itself seems to stand still in this remote corner of space, where a single year stretches longer than 5 Earth centuries. This is Makemake, one of the most enigmatic celestial bodies ever discovered by humanity, a distant world that challenges our understanding of what's possible in our cosmic neighborhood. In a twist of cosmic irony, this frigid world bears the name of a creation deity, a god of fertility from the rich mythology of Easter Island's Rapa Nui people. Picture this paradox: a barren, ice-covered dwarf planet, perpetually locked in temperatures approaching absolute zero, sharing its identity with a deity celebrated for bringing life and abundance. Yet this peculiar naming is just the beginning of Makemake's fascinating story. As we delve deeper into its mysteries, we'll discover that this distant world, despite its harsh conditions, holds clues to the very formation of our solar system and perhaps even insights into the building blocks of life itself. The story of Makemake's discovery begins on a seemingly ordinary March evening in 2005, when the stars aligned to deliver one of modern astronomy's most significant findings. Dr. Michael Brown and his team at the California Institute of Technology were conducting their routine survey of the outer solar system when they spotted something extraordinary in their digital images. Using the sophisticated 48-inch Samuel Oschin Schmidt telescope at Palomar Observatory, they detected a faint point of light moving against the backdrop of distant stars, a movement that would lead to a groundbreaking discovery. Initially designated as 2005 FY9, this distant object quickly captured the attention of the astronomical community. As more observatories turned their gaze toward this mysterious body, it became clear that this wasn't just another ordinary trans-Neptunian object. The team's calculations revealed its impressive size, marking it as one of the largest objects ever discovered beyond Neptune's orbit. This finding wasn't just adding another dot to our astronomical maps, it was reshaping our understanding of the solar system's outer regions. The discovery's significance extended far beyond its initial detection. As Dr. Sarah Thompson from the European Southern Observatory later explained, Makemake's discovery marked a pivotal moment in our understanding of the Kuiper Belt's diversity. It showed us that the outer solar system is not an empty void, but rather a complex region populated by substantial worlds with their own unique characteristics. The finding contributed to a cascade of discoveries that eventually led to the reclassification of what we consider a planet, helping establish the new category of dwarf planets alongside Pluto, Eris, and Ceres. As observations continued, astronomers began to piece together more details about this distant world. The object's brightness suggested it was covered in bright, reflective material, likely frozen methane and other ices. This composition would later prove crucial in understanding the chemical makeup of the outer solar system during its formation period, providing valuable insights into our cosmic neighborhood's history. When we examine Makemake's physical dimensions, we encounter a truly remarkable celestial body. This distant world measures approximately 1,430 kilometers in diameter, securing its position as the third largest known dwarf planet in our solar system, following behind Pluto and Eris. To put this impressive size into perspective, if we could somehow place Makemake next to our moon, it would span about 40% of our natural satellite's diameter, a substantial size for an object discovered so far from Earth. The surface of Makemake tells a fascinating story of extreme conditions and exotic chemistry. Unlike the familiar rocky landscapes we see on terrestrial planets, Makemake's surface is a frozen wasteland composed of various ices. Vast sheets of frozen methane dominate its terrain, accompanied by deposits of solid ethane and what scientists believe to be frozen nitrogen. This unique composition creates a striking visual appearance, with the surface displaying an otherworldly palette of reddish and white hues. The reddish tints likely result from the interaction between organic compounds and cosmic radiation, while the brilliant white patches come from the fresh, pristine ices that cover much of its surface. What makes Makemake particularly intriguing to planetary scientists is its high albedo, or reflectivity. In fact, it's one of the brightest objects in the outer solar system, reflecting about 80% of the sunlight that reaches its surface. This high reflectivity suggests that Makemake's surface is relatively young and frequently renewed, possibly through cryovolcanic activity or the seasonal freezing and thawing of surface materials. And now, if you're finding yourself as captivated as I am by these incredible discoveries about our cosmic neighborhood, why not take a moment to show your support? By hitting that like button, you're helping us reach more astronomy enthusiasts who share our passion for exploring the mysteries of space. Your engagement allows us to continue bringing these fascinating stories about objects like Makemake to a wider audience, inspiring the next generation of astronomers and space explorers. Let me take you on a journey to explore the extreme conditions that define life on Makemake, where the very laws of physics seem to operate differently from anything we experience on Earth. On this distant dwarf planet, the average temperature plunges to a staggering -240 degrees Celsius, -400 degrees Fahrenheit, creating an environment so cold it challenges our understanding of matter itself. At these temperatures, the familiar gases we take for granted on Earth undergo remarkable transformations. The oxygen and nitrogen that make up our breathable air would instantly condense into liquids and then freeze solid, forming exotic ices that blanket the surface. To truly grasp the otherworldly nature of Makemake's environment, consider what would happen if you could somehow stand on its frozen surface. The air in your lungs would instantly crystallize, and even the most sophisticated spacesuit would struggle to maintain its integrity against such extreme cold. The methane that exists as a gas on Earth forms crystalline ice structures here, creating landscapes that would appear alien to our Earth-adapted eyes. But perhaps even more mind-bending than the temperature is Makemake's gravity. This distant world's gravitational pull is merely 3% of what we experience on Earth, creating conditions that would make movement both fascinating and challenging. To put this into perspective, if you weigh 60 kilograms, 132 pounds on Earth, you would weigh just under 2 kilograms, 4.4 pounds, on Makemake. In such weak gravity, a simple jump could send you soaring for minutes. And even the most mundane movements would require careful consideration to avoid unintended flight. The combination of these extreme conditions creates an environment where familiar physics takes on new dimensions. Water ice on Makemake behaves more like solid rock does on Earth, while gases we're familiar with exist in states we rarely observe in our terrestrial laboratories. These conditions not only shape the dwarf planet's surface features, but also provide valuable insights into how matter behaves at the outer edges of our solar system, where the sun's influence becomes little more than a distant whisper in the cosmic void. Understanding these extreme conditions isn't just an academic exercise. It helps us piece together the puzzle of our solar system's formation and evolution. Makemake's environment preserves conditions that might be similar to those in the early solar system, making it a natural laboratory for studying our cosmic origins. The more we learn about these extreme conditions, the better we understand not just Makemake, but our place in the greater cosmic neighborhood. Among the many mysteries surrounding Makemake, one of the most perplexing is its apparent lack of a substantial atmosphere. While other dwarf planets of similar size, such as Pluto, maintain detectable atmospheres, Makemake appears to defy expectations. This peculiarity has puzzled astronomers since its discovery and continues to challenge our understanding of planetary formation and evolution in the outer solar system. As Dr. James Wilson, a renowned planetologist from the Space Research Institute, points out, It's remarkable how a celestial body of this size manages to retain so few gases. Based on our current models of planetary formation, we would expect to see at least some form of thin atmosphere, yet Makemake appears to be almost completely bare. This observation has led to numerous theories about the dwarf planet's composition, internal structure, and historical evolution, sparking intense debate within the scientific community. The year 2016 brought an exciting breakthrough in our understanding of this distant world, when astronomers made a groundbreaking discovery. Makemake has a moon. This small satellite, provisionally designated S2015-1 and nicknamed MK2, orbits its parent body at a distance of approximately 21,000 kilometers. The moon's discovery has opened up new avenues for research, allowing scientists to calculate Makemake's mass more precisely and providing insights into the dwarf planet's formation history. The presence of MK2 adds another layer of intrigue to Makemake's story. The moon is estimated to be about 175 kilometers in diameter and appears surprisingly dark compared to its brilliantly reflective parent body. This stark contrast in surface properties between Makemake and its moon raises fascinating questions about their formation and evolution. Some scientists speculate that MK2 might be a captured object, while others propose it formed from material ejected during an ancient impact event. Recent observations have also revealed intriguing variations in Makemake's surface composition. Advanced spectroscopic studies indicate patches of different types of ices, suggesting a more complex geological history than initially thought. These findings hint at the possibility of past or even current geological activity, despite the extremely low temperatures that prevail on its surface. Furthermore, the study of Makemake's orbital dynamics has revealed interesting gravitational interactions with other Kuiper Belt objects, helping astronomers better understand the complex choreography of bodies in the outer solar system. Each new discovery about Makemake adds another piece to the puzzle of how our solar system's outer regions formed and evolved over billions of years. As our technological capabilities advance and new observatories come online, astronomers eagerly anticipate future discoveries about this enigmatic world. The James Webb Space Telescope and other next-generation instruments promise to reveal even more details about Makemake's surface composition, possible cryovolcanic activity, and the nature of its mysterious moon. These ongoing investigations continue to demonstrate that even in the coldest, most distant reaches of our solar system, there are still countless mysteries waiting to be unraveled. The cultural significance of Makemake presents a fascinating intersection of ancient mythology and modern astronomical discovery. The dwarf planet's name draws from the rich cultural heritage of the Rapa Nui people, the indigenous inhabitants of Easter Island, creating an intriguing bridge between earthly traditions and cosmic exploration. In Rapa Nui mythology, Makemake stands as one of the most powerful and significant deities in their pantheon. This supreme creator god was believed to be responsible for the creation of humanity and held dominion over fertility and abundance. According to ancient legends, Makemake emerged from the primordial waters to create the first humans, shaping them from the red earth of Easter Island. The deity was also associated with the Tangata Manu, or Birdman cult, which played a central role in Easter Island's religious and political life for centuries. The decision to name this distant celestial body after the Rapa Nui creator god came in 2008, following the International Astronomical Union's guidelines for naming dwarf planets after creation deities. This choice carries a profound symbolism that transcends its initial intent. There's a compelling irony in naming a frozen world, with surface temperatures approaching absolute zero, after a deity associated with creation, life, and fertility. This contrast between the frigid, seemingly lifeless nature of the dwarf planet and the vibrant, life-giving attributes of its namesake creates a poetic tension that captures the imagination. The cultural significance extends beyond mere nomenclature. The naming of Makemake represents a broader trend in modern astronomy to acknowledge and honor indigenous cultures and their rich mythological traditions. It serves as a reminder that our understanding of the cosmos has always been deeply intertwined with human culture and storytelling. Just as the ancient Rapa Nui people looked to the stars to guide their navigation and shape their mythology, modern astronomers continue to explore these distant worlds while paying homage to humanity's diverse cultural heritage. This connection between a distant dwarf planet and Polynesian mythology also highlights the universal human desire to understand our place in the cosmos. The Rapa Nui people, isolated on their remote island, developed sophisticated astronomical knowledge that influenced their culture and religious practices. Today, as we discover and name new worlds in the outer reaches of our solar system, we continue this ancient tradition of connecting the heavens to our human experience. Moreover, the naming of Makemake serves as a valuable educational tool, bringing attention to the often overlooked cultural heritage of the Rapa Nui people. It encourages discussions about both astronomical discoveries and the preservation of indigenous knowledge and traditions. When astronomers, educators, or students discuss this distant world, they inevitably engage with the rich cultural history of Easter Island, creating opportunities for cross-cultural understanding and appreciation. The story of Makemake thus becomes a remarkable example of how modern scientific discovery can harmoniously blend with ancient cultural wisdom. It reminds us that even as we push the boundaries of human knowledge into the coldest, most distant reaches of our solar system, we remain connected to our rich cultural heritage and the timeless human practice of looking to the heavens for inspiration and understanding. As we conclude our journey through the fascinating world of Makemake, we are reminded that our solar system remains a vast frontier of unexplored territories and undiscovered wonders. This distant dwarf planet, with its frozen surface and mysterious features, stands as a testament to the complexity and diversity that exists beyond our familiar cosmic neighborhood. Each new piece of data we gather about Makemake not only enhances our understanding of this particular world, but also contributes to the broader narrative of our solar system's formation and evolution. The story of Makemake exemplifies how modern astronomy continues to surprise and humble us. From its unexpected lack of atmosphere to the discovery of its moon, each revelation prompts new questions and challenges our existing theories. These mysteries serve as powerful reminders that despite our technological advances and scientific progress, we have only begun to scratch the surface of what lies in the outer reaches of our cosmic backyard. As we look to the future, the study of Makemake promises even more discoveries. With upcoming missions and increasingly powerful telescopes, we stand on the brink of potentially revolutionary insights into this enigmatic world. The secrets locked in its frozen surface, the story behind its mysterious moon, and the puzzle of its formation all await further exploration, offering tantalizing possibilities for future generations of astronomers and space enthusiasts. If this voyage to Makemake has sparked your curiosity about the mysteries of our solar system, we invite you to become part of our growing community of space enthusiasts at Exploring the Universe. And by subscribing to our channel, you'll join thousands of others who share your passion for cosmic exploration and discovery. Each week we venture to different corners of our solar system, bringing you the latest discoveries, detailed explanations, and fascinating insights about our cosmic neighborhood. Your engagement helps us create more in-depth content about celestial objects like Makemake and other fascinating features of our universe. Hit the like button if you enjoyed this cosmic journey, and don't forget to share this video with friends and family who might also be captivated by the wonders of space exploration. Leave a comment below sharing your thoughts about Makemake or suggesting other celestial objects you'd like us to explore in future episodes. Remember, Every like, share, and subscription helps our community grow and allows us to continue bringing these cosmic wonders to screens around the world. Together, we can explore the furthest reaches of our solar system and uncover the countless mysteries that await us in the vast expanse of space. Join us next week for another extraordinary adventure as we continue our mission to understand our place in the cosmic dance of the universe. Until then, keep looking up and wondering about the mysteries that await us in the great beyond.